All right, example 3. So in this example, we have some vertical translations going on. We have this 3 plus and this negative 3 plus, and I'm also seeing some horizontal translations. We're adding and subtracting in here by the x. Also a phase, sorry, not a phase shift, but we're changing the period in C and D with that 2 inside of our sine and cosine function. Okay, so let's look at these that are being shifted vertically first. So this one should be shifted up 3. This one's going down 3. So these should be pretty easy to pick out. You can see this one right here. This one's been shifted up 3. Notice the middle line is at 3 now. So this is B. Okay. And this one right here is not centered around 0 anymore. It's been shifted, and now the center is at negative 3. I did a very bad job of drawing that line in, but, you know, sometimes it'd be like that. Okay, nice. So for these next ones, we need to look at this horizontal shift. Both of these are being shifted in the same way. We have that minus pi halves. Minus pi halves is a right pi halves. So what I'm going to do is I'm actually going to look over pi halves at both of the graphs that are left here. So I'm going to look at pi halves and kind of think of that as like the starting point. Then I'm going to look at what the curves do. So this one at pi halves, it starts in the middle, goes up and back down. That looks like a sine curve to me. And this one starts at the top and goes down. So that's more of a cosine one. So we can kind of tell them apart just by looking for which one is sine and which one is cosine. But we should double check that this period change is represented there too. So if I look at this sine curve, look at where it would end, right there back at the middle. So it's kind of hard to see, I covered up there, but this says pi halves, this is pi, and then there's one in the middle. In between pi halves and pi is 3 pi fourths. So it looks like each one of these tick marks is counting by pi fourths. So we'd be down here at the bottom at 5 pi fourths. And then we would finish up right here at 6 pi fourths, which is the same thing as 3 pi halves. So the whole period happens from pi halves to 3 pi halves. Which, if you think of the circle, that's just from the top half of the circle, pi halves, to 3 pi halves. So that happened in just 180 degrees, so like pi. So this period is only pi, which makes sense because we have that 2 there saying that we're going 2 times as fast. So we would complete an entire cycle in pi instead of 2 pi. Same thing is going on here. You can see that pi halves. So this will be pi fourths, 3 pi fourths, sorry. And then we'd have 5 pi fourths, and our cosine curve will finish when we're back up at that maximum, so we get that entire cycle, which will happen at 6 pi fourths, which is the same thing as 3 pi halves. So we went all the way from pi halves to 3 pi halves, which is a distance of pi. Cool. So let's write our final things. This was the sine one, so A, bam, and D, straight here. Awesome. Okay, for these next ones, first a little bit of information. So if you're given a graph and you're asked to write the equation for it, this is kind of a little walkthrough. So you might want to have this printed out or written out for when we do our test, a walkthrough of steps for writing sinusoidal functions. So kind of a guide of how to think about or how to break apart the graph. So first, the first thing we do is it'd be nice to decide whether we should use sine or cosine as the parent function. And you just look at that by saying like, well, does it start at the top and then go down, or does it start in the middle and then wave around? That's what you really want to know. Okay, after that, once you've decided whether you should use sine or cosine, then we can decide if it should be reflected or not. Like, does it actually start at the bottom and go up if it's cosine, or does it start in the middle and then go down and then up? Should it be reflected? Okay, once you've decided if it's sine or cosine, if it should be reflected or not, the next thing you want to do is you want to identify the max and the min value. So just look at the graph and see where's the top, what's the maximum value it reaches and what's the minimum value it reaches. Pretty self-explanatory, I think. Next thing that we do is we're going to decide if we should shift it vertically. So should it be shifted up or down at all? And I like to, in here, once you find the max and min, find the midline, which should be halfway in the middle. And the distance between the midline and 0 shows you like how much it should be shifted vertically. One way to find the midline is to do this maximum plus minimum divided by 2. Okay. Yeah. Yeah, okay, yeah. Had to think about that for a second, but yeah. Okay, once you've decided the midline, then you can look at the distance between the midline that you found and the maximum min to find the amplitude. And then lastly, two more things. Decide if we need to change the period. So decide if we need to change the period. And then lastly, decide if we need to shift left or right at all. So that's kind of going to be our guide for looking at these graphs. So here we are. We're going to write a sine function for the graph. So luckily on this one, they told us we're just going to start with sine so we know where we're going. So type of function, we're going to do sine because they told us. Otherwise, maybe I would do cosine and just make it flipped over and say it goes like that. But we're going to do sine. So sine, I need to look for, it looks like, try to find the middle in here. Okay. Well, I'm going to say that I'm going to do sine. And then we'll follow the rules. Max. The max value is right up here. Apparently that happens at 5. They told us the max is 5. And the min is right down here at -3. Okay, so if we're halfway in between 5 and -3, halfway between 5 and -3, how I would think about that is the total distance between them is 1, 2, 3, 4, 5, 6, 7, 8. So halfway in between them should be 4 on either side, which is going to put us right here at y equals 1. And you might be able to see that just from looking at the graph. But our midline, mid, is at y equals 1. And that means the amplitude, so how far up and down do we go from that? We're going 4. So our amplitude should be 4. Okay. Vertical displacement. So we already saw our midline was up 1. So it's like it got shifted up 1. Up 1. And period 2 pi over b. So b equals, okay, so let's look for a period of this guy. So I'm going to look for my sine function. So here's one place where it starts in the middle. You can pick any of these and just see how long it takes to get back to the middle. So this started at pi, and it went all the way to, let's see, what's this? Oh, look, they labeled this part as being 4 pi. So I think this one right here is 4 pi, and they labeled that as being 2 pi. So it looks like we're just counting by pi's. Pi, 2 pi, 3 pi, 4 pi. So apparently, this is finishing at 5 pi. Okay. What's the difference between pi and 5 pi? Well, the difference is 4 pi. So our period is 4 pi. Normally it should be 2 pi, so it's like we're going half the speed. So another way we can say that is we said our period is 4 pi, so if we fill that in, period 4 pi equals, but using our little formula, we have 2 pi over what we're looking for is b. Okay, so we can rearrange that, multiply both sides by b, to get that over there, and then now we have b times 4 pi equals 2 pi, and we can divide both sides by 4 pi to get b by itself. And 2 over 4 simplifies to be 1/2, and pi over pi is just a 1, so it's just 1/2. So our b should be 1/2, kind of like we said that we're going half the speed, because it took us 4 pi to finish instead of 2 pi. Okay, phase shift, yes, we saw when we highlighted our sine function, it's not starting right at the beginning, it's starting at pi. So we got shifted to the right, pi. Reflection, we don't need a reflection because we start in the middle and go up and then down, so no reflection. So it looks like our final answer is going to be, let's put all of this together. We're going to have y equals, our amplitude we said is 4 and it's not reflected, so just 4. We're doing a sine graph. Okay, we have that 1/2, so 1/2. And we should go right pi, which means we need x minus pi. Put it in just like that. And we need to go up 1, so plus 1. I think we got everything in there. Wonderful. Let's try another. This time we're going to write a cosine graph, or a cosine function. So what type of graph? We're going to do cosine. What's our max and min? Our max is right here at 5 again. Our min is at -5. Interesting. So right in between 5 and -5, that midline is just 0. So amplitude in between 0 and 5, I'm going to go ahead and kind of highlight my midline in here. Here's the middle right there. How far do we go up and down from that? Well, we go up and down 5. So our amplitude is 5. Vertical displacement, our midline stayed at 0, so no vertical displacement. And let's see how long our period is. So let's find one of these cosine guys. I'm seeing like this as being a cosine guy. Normally cosine starts at the top, but this one will just be reflected. And I can say that down here already. Reflection? Yeah, let's reflect it. Okay, but let's look at the period. So this little one I highlighted, this one cycle that I highlighted starts at 0 and ends at, let's see, this is marked as pi thirds. So that next one should be 2 pi thirds. So it looks like our period, our cycle went from 0 to 2 pi thirds, which means our period is 2 pi thirds. Kind of interesting. Okay, so if I want to know what b is, that's what we need to plug into our thing. Well, 2 pi thirds is our period equals 2 pi over b. Well, you could solve this, or you could just be like, well, hey, 2 pi over, that means b's got to be 3. In other words, we're going 3 times as fast because our period happens in 2 pi thirds instead of 2 pi. Okay, and then a phase shift. We don't need a phase shift. We're starting right here. We're just going to be reflected, so no phase shift. Okay, our final answer for this one is going to be y equals, look for the amplitude, 5, so 5. Oh, and a reflection, so -5. Cosine. Okay, next look for the period, so b is 3. Phase shift, no, so we don't need any plus or minus inside by the x, and we didn't shift up or down, so we don't need anything else there. It's just -5 cosine of 3x. All right, let's do one more of these. We're going to write another cosine function. So that was so fun the last time. Okay, type of function, cosine. Max value, 0.5. Min value, this is different. Let's see, so we got to be careful with this. So if this is 0.5, then that tally mark must be 0.25. That means what? -0.25 and then -0.5. So our min is -0.5. That means our midline, you can see right there, is still just 0. So mid is 0. So our amplitude, max minus the min over 2, or you can just say how far up and down, how far are we wiggling up and down from that midline? Well, we're going up and down 0.5. Okay, vertical displacement, none. Our midline's still sitting there at 0. We didn't shift it up or down at all. Okay, period equals 2 pi over b. So let's see if we can find a period in here. We're looking for a cosine function, so I think I'm going to highlight this guy. Starts at the top, just like that, ends right there. Or if you wanted, you could do this one. Then you just have to reflect it. So your formula might look different, and that's okay. It's up to you. I think I'm going to take this one, though. Yep. Okay, so this cycle, let's see where it starts and ends. So this cycle started right here. Okay, so this is 1, this is 2. So it looks like each tally mark is a half. So it's starting at 0.5, and it's ending, it's going to end 1 after this 2, so it's ending at 2.5. So that means my period is from 0.5 to 2.5. My period is 2. Okay, so let's use this formula. My period is 2 equals 2 pi over b, and we need to solve for b. Okay, so I'm going to multiply both sides by b to get it out of that denominator. Now I have on this side 2b, 2 times b equals 2 pi. Well, okay, at this point you can divide both sides by 2, but I think we can see that b has to be pi. So we get b equals pi. All right, phase shift, yes, like we, our cycle that we highlighted doesn't start right here at the y-axis. So we shifted it over, this shifted it over 0.5, so we went right, 0.5. then right is going to be a minus 0.5. And a reflection, nope, we started at the top, so we don't need a reflection. So our final thing is going to be y equals, look for our amplitude, 0.5. So you can do 0.5, or if you wanted, you could do 1/2. I like fractions more, so I'm going to do 1/2. And we're doing a cosine, so cosine. All right, did we change the period? Yes, we have that b is pi. And then x, we need to go right 0.5, so I need a minus 0.5 in there. Bam, bam. And we didn't go up or down, so that's everything that's left there. Wonderful. Okay, just a couple more. So this one says, recall the following about the London Eye Ferris wheel. It's 443 feet in diameter, so all the way top to bottom is 443 feet. One revolution takes 30 minutes, and it rotates continuously in a counterclockwise direction, meaning we're going this way. Okay, that's counterclockwise, I think. Around this way. And passengers board the wheel at ground level, so you just board right there at ground level. Okay, cool. Write a trig function using, if necessary, the smallest phase shift possible to model the height above ground as a function of time. Okay, so here we go. You can see here, this looks like what we did for our roller coasters. You can see that diameter right there. It's going from 0 to 443, and they said the diameter is 443. You can see the midline is kind of right here. Maybe I'll highlight that in purple. I think that's what I was doing before. So midline right here. And one way that you could find the midline, if you don't just want to see it, you can say like, oh, look, here's the max value. Max 443. Min value is 0. Because that's when you're like boarding or getting off. Min is 0. So right in the middle, we just have 443 plus 0 divided by 2, which is 221.5. You can see right there. Okay, so that's the mid. All right, so we need to decide whether we want to use a sine or a cosine function. I'm thinking right from the beginning, it starts at the bottom and then goes up. So I'm thinking we could just use a cosine and just have it be reflected, so it starts at the bottom. So I'm thinking, okay, I'm going to use cosine. I found my midline. It'd be really nice to figure out my period. I think that might be next. Maybe I'll come look up here. Max, min, amplitude. We figured out the amplitude. Vertical displacement. Oh, we should figure out our vertical displacement. Well, we kind of did because we found out our midline is 221.5. So yeah, let's find the period. Okay, so the period is, it takes 30 minutes, right? 30 minutes to get all the way done. So let's try to write this. Our period. We know that our period is equal to 2 pi over b. B is what needs to go into our formula. So we have 30 minutes equals 2 pi over b. If we want to solve this, I'd multiply both sides by b. And now I have 30b equals 2 pi. And just divide both sides by 30. Okay, 30 over 30 is a fancy 1, so that just leaves 1b. 2 pi over 30, I can simplify that to be pi over 15. So it looks like b is going to be pi over 15. Okay, I think we're ready to go. So I'm going to have y equals, we decided we wanted a cosine, but the amplitude, notice the amplitude, how far do we wiggle up and down from the midline? This is up 221.5 and down 221.5. So our amplitude is 221.5, and we said it should be reflected because we're starting at the bottom instead of at the top, so we're going to do negative 221.5 as our A. Cosine, okay, changing our period, that B needs to be pi over 15. X, we're not shifting left or right because we started that cycle we highlighted, started right at 0, so we're done with that. But then we have to shift our midline, we have to shift the whole thing up 221.5. Nice. Now you could also do that with a cosine function if you wanted to, or a sine function if you wanted to. You just say, oh, it starts right here and goes up and comes back here. So you could do that. It wouldn't have to be reflected since it goes up and down, but you would have to do a phase shift, right? Because it would start at 7.5. So that would look a little bit different. In fact, I'm just going to go ahead and write down what that would be here. If you wanted to do it as a sine function instead, you could do that as y equals. It doesn't need to be reflected, but the amplitude would still be 221.5 sine. The period's going to be the same, so pi over 15. But then you'd need to shift to the right 7.5, so we do x minus 7.5. Bam, bam, and then still plus 221.5. So that's what it would look like if you did it as a sine function instead of a cosine function. I kind of think the cosine one's easier. If you can avoid phase shifts, that's nice. Phase shifts just kind of complicate stuff. Okay, last one here. Excellent. Okay. All right, now we're writing a different Ferris wheel. The given function models your height above ground in meters as a function of time in minutes. Okay. So let's pick off the different parts. We have an amplitude of 50, and it's reflected. That's what that negative means. Our period is being affected by this pi over 10. We don't have a phase shift because we're not adding or subtracting anything to x. It's t in this case, but the variable in there. And we have a plus 53. So I'm just going to kind of mark, this is up 53. This is reflect or flip and amplitude 50. This pi over 10 means we're going pi over 10 the speed. So it means our period is 2 pi divided by pi over 10. And when I divide by a fraction, I need to flip and multiply. So 2 pi times 10 over pi. So pi over pi, this is just 20. So apparently our period is 20. Okay, so sketch the graph of one cycle of h of t and label each axis. So I already said the period's going to be 20. So I'm just going to go ahead and put a 20 out here. 20. And then I like to do, break it up. So we're going to break that 20 in half, and half of 20 is 10. Half of 10 is 5. So then in between 10 and 20 would be 15. Then we can get a full cycle in here. Okay. We need to go up 53. So I'm going to just go ahead and put 53 in here, right there. Well, maybe not quite that high. How about 53 right here? Just going to label that as my midline. Thinking of shifting it up 53. One thing we can do also is we can look at this Ferris wheel picture. What does this mean to us? Well, it means the diameter, we're going up and down from 50. So what's our max height going to be? Well, it's going to be 53 plus 50. So our max height is going to be 103. Our min height is going to be 3. That's where we're going to be loading. And the center is going to be 53 feet right there. And you can see that amplitude of 50 right here. Anyway, okay. We're almost there. Well, I think we're about ready to go. Now that we know the midline, the only thing we have to be careful about is that we remember it's reflect. So if we're doing sine and it's reflected, we start in the middle, but then we go down. Oops, but we don't want to go all the way down to 0 because our amplitude is 50. So we need to go up 50 and down 50. So up 50 from 53 is going to take us to 103. Down 50 from 53 is going to take us to 3. So I'm going to go ahead and kind of bound myself in here so I know where to put my wave. So we're going to go up, down. We're reflecting, so we start in the middle, then we go down, back to the middle, up, middle. It'll look like this. Oops. Awesome. Okay. That's our graph. Okay, how high above ground are you at t equals 0? So when you started measuring this, t equals 0. Oh, we forgot to label our axes. That's going to help us. This down here is time. It's t, time. And this is height. And height in meters. Time is in minutes, I'm sure. Yeah, time, t in minutes. Okay, so it wants to know, when you first started counting, how high are you? So at time t equals 0, here's time t equals 0. Well, you started right there at 53 meters above ground. So we were 53 meters. Okay, what is your position on the wheel when t equals 0? That is, what is your o'clock? Okay, that's kind of weird. One thing that we should say, we're going to assume that our Ferris wheel is turning counterclockwise. It's turning this way. So we're either at this far right point or this left point, but we're going to look at our graph and say we're about to be going down after this. So I think we're at this far left point right here, because we're about to be going down and we're turning this way. So what's our time o'clock? That would be, can I read a clock? 9 o'clock. That's our position on the wheel, 9 o'clock. What direction is the wheel rotating? How do you know? Oh, well, I said that counterclockwise. Because we're about to go down. Okay, what is the diameter of the wheel? Okay, so the lowest point was 3, the highest point is 103, so the diameter is 100, the whole thing, 100 meters. How long does one revolution take? Well, it takes 20 minutes. That's what we figured out with the period. Find the max and minimum heights above ground. Oh, we did that. So the max height that you got was 103, because you're lifted. The middle is 53, you go up 50. Max, so max is 103 meters. And the min is 3 meters when you're like scraping the ground at the bottom. If you've been riding the Ferris wheel for 45 minutes, what is your position on the wheel? Okay, this is a good question. So one thing I notice here is that in 45 minutes, you've completed 2 full rotations, right? Because at 40 minutes, like at 20 minutes, you're back at the start. At 0 minutes, you're at the start. Like you're at 9 o'clock. 9 o'clock. 20 minutes, you're back. You've done a full rotation. So 40 minutes, you're back. You've done a full rotation. So really, we can just say like 45 minutes, it's going to be the same position we are in at 5 minutes. So let's look at our graph at 5 minutes. Here we are at 5 minutes. We are all the way down at the bottom. So we're 3 feet. If you've been riding, what is your, position on the wheel though? 3 feet. So we're all the way at the bottom. That's our position on the wheel. So like 6 o'clock, all the way at the bottom. Seems weird that you started counting at the 9 o'clock position, but whatever. Okay, that's it. So that's our graphing, sine and